Hey guys, it's Mr. Oda. In today's video lesson, we're going to be talking about topic 3.4, carrying capacity. Now, this is a topic that you've been introduced to in living environment. We are going to take it a step further in environmental science. For our learning objectives today, we're going to be able to describe carrying capacity, but also describe the impact of carrying capacities on ecosystems. As for the skill we're going to be practicing today, we're going to be looking at a lot of data and we're going to explain what that implies or illustrates about different environmental issues. Now, as you've seen carrying capacity before, carrying capacity in environmental science is represented by graphs normally that look like this. It's represented by the letter K, and it limits the growth of a population. Carrying capacity is the maximum number of organisms an environment can support without the resources being degraded. When you see a population first grow, they're going to grow with their biotic potential, meaning their maximum reproductive rate, because there's enough resources for them, their population is small. But as they get bigger, they get closer to the carrying capacity, they're going to start to level off. And that usually happens with K selected species, which is why we represent carrying capacity with the letter K. K selected species usually grow in a logistic growth model, which means they grow faster first, start to slow down, and then level off around their carrying capacity. On the other side, though, R selected species tend to grow exponentially very quickly because they reproduce very fast. Now, the question is, what happens if a population goes over its carrying capacity? More often than not, population will grow very quickly and it can go over its carrying capacity. That means that there are more organisms than the environment can support. And what's going to happen next is what we call a dieback. There won't be enough resources for the organisms, and so they will drop down. At first, they overshoot their carrying capacity, and then the dieback is when the organisms start to die off. Now, normally this will happen back and forth. The population will hover around its carrying capacity, sometimes a little bit above, sometimes a little bit below. Now, looking at this graph shows the populations of wolves and moose on Isle Royale. Describe how the two populations are related. Try to utilize the scientific vocabulary, carrying capacity, and dieback. One thing you guys will observe as you're doing this is that the populations are linked. As the wolf population goes up, they start to consume more moose. And when the moose population goes down, so does the wolves shortly after. Now, one key thing to remember is that if a population overshoots its carrying capacity by too much, the dieback can actually be very catastrophic. This image shows the population of reindeer on St. Matthew Island. Now, there was a huge spike in their growth in the mid-1960s, but soon after, it dropped to almost nothing. Two questions for you guys. Why do you think the reindeer population grew so fast to begin with? And for question two, why do you think the reindeer population had such a large dieback and almost went extinct? There are many hypotheses about why the reindeer grew so fast. It could be because of lack of natural predators, a lot of resources, but because they grew so quickly, they eventually depleted the resources. There was no more food for them. And so because of that, instead of just dropping a little bit, they completely almost went extinct in this island. Now, to make sure we got the idea of carrying capacity, we're going to have a couple of formative assessment questions using this graph on the population of a large grazing herbivore. For question one, looking at the graph, what's the best estimate for the carrying capacity of this herbivore? For question two, explain whether this organism is a K-selected or R-selected species. And for question three, identify some potential causes for the herbivore's population fluctuating. especially between the years of 1980 and today, 2020. Okay. Hopefully, you would have gotten that the carrying capacity is somewhere along the lines of 1,400. And we will see if this is a case selected or selected species later on.